Hi everyone, before going to watch this video, subscribe my channel and click on the which button? Bell button to receive the notifications of all the videos. So acceleration means the rate of change of velocity. So students, today we are going to study about a new topic, that is acceleration. Before going to that acceleration, I want to revise what we have studied in the previous video. Motion we have divided into two types. One is uniform motion, another is non-uniform motion. In uniform motion, what happened? What are the conditions for uniform motion? In uniform motion, the speed or the velocity was constant throughout the motion. Yes or no? Velocity was constant throughout the motion. Velocity constant. Yes. But in non-uniform motion, velocity is not constant. That is variable velocity. Variable velocity. That means in this type of motion, velocity is getting changed time to time. Yes or no? So in this, change in velocity is zero. Change in velocity is zero. But in this, there is some change in velocity. Okay? In this non-uniform motion, since velocity is getting changed, we will come into this new word, that is acceleration. This non-uniform motion is called as accelerated motion. Remember, accelerated motion. Accelerated motion. So acceleration is there in this non-uniform motion. Getting? And in uniform motion, acceleration is not there. So acceleration in uniform motion equal to zero. Change in velocity is zero. That's why acceleration is zero. Remember, in uniform motion, acceleration is zero. But in non-uniform motion, there is some change in velocity time to time. That's why it is called as accelerated motion. Then from here, what we are getting the definition of acceleration, that is change in velocity per unit time. Per unit time. This is the definition of acceleration. Change in velocity per unit time. So remember this diagram. This is very much important because many times student gets confused whether acceleration is there in uniform motion or not. Why I will tell later. So remember this one? Okay, listen. So as acceleration definition is change in velocity per unit time. Already we have studied before. If at the starting of motion or at the when we are considering the initial velocity, if initial velocity equal to u, final velocity equal to v. अच्छा u से v होने के लिए लेट्स टाइम इक्वल टू t. लेट्स टाइम इक्वल टू t. इनिशियल वेलोसिटी से फाइनल वेलोसिटी होने के लिए टाइम इक्वल टू t. ओके, सो इफ वी विल डिफाइन हियर एक्सीलरेशन इक्वल टू व्हाट इज द फार्मूला? चेंज इन वेलोसिटी पर यूनिट टाइम. अच्छा, चेंज कितना हुआ है? दैट इज u टू v. दैट मींस चेंज इन वेलोसिटी इज v माइनस u पर यूनिट टाइम, दैट इज t. So v minus u by t. Final velocity minus initial velocity divided by time or t. Getting this? So acceleration is change in velocity per time t. This is very much important. Remember. First you remember this, then we will go to different types of acceleration. Okay? So in acceleration, if we will go to unit of acceleration, as we know, every physical quantity we will study about unit first. So a equal to v minus u by t. Yes or no? Yes. So we will find unit. So here velocity per time. Velocity unit is SI unit is meter per second. Time unit is second. So the unit will be meter per second square. Okay, getting my point? So meter per second square is the SI unit of acceleration. If other units we will see, then we can find kilometer per second square. Yes or no? Right. Kilometer per second square. Other units we can find also, that centimeter per second square. Got it? So these are about unit of acceleration. Next we will see it is scalar or vector. Scalar or vector. So here, as you can see here, velocity is a vector quantity and time is scalar. So velocity is vector quantity present here. That means acceleration will be a vector quantity and having direction. Getting? So always remember acceleration is a vector quantity.
So how to write?
Getting? So after this we will take an example about acceleration. An object changes its velocity from 2 meter per second to 4 meter per second in time 4 seconds. Find the acceleration of the object in this 4 seconds. The question is like this. So here you can find initial velocity is 2 meter per second, final velocity v 4 meter per second, time equal to 4 seconds. So acceleration a equal to v minus u, that is final velocity minus initial velocity divided by t, that is 4 meter per second minus 2 meter per second divided by 4 seconds. Getting my point? So this is 4 minus 2, 2 meter per second by 4 seconds. That means in 4 seconds the velocity is getting changed by 2 meter per second. So here 2 by 4 meter per second square. This is the answer. And if we will take 2 by 4, it is 0.5. 0.5 meter per second square. Getting? This is the answer. So this type of problem can come. So you have to answer like this. First write the formula properly. First given details, then formula, then find the answer. Clear? And don't forget to mention the unit here. This is very important. If you are not mentioning the unit, then no mark will be given for that problem. Clear about it? Next is positive acceleration, negative acceleration. Positive acceleration, negative acceleration. What is this? If the velocity is getting changed in a positive manner, that means when we are going in a downward way, or the velocity is getting increased, that means if you are going in a vehicle and your velocity was 20 meter per second and it is getting, you are accelerating the vehicle so that you are getting a speed of 40 meter per second. So the velocity is getting in a positive way, that means it is positive acceleration. If you are going in a speed of or velocity of 80 meter per second and it is getting decreased due to applying brake and it is converted to or coming to 50 meter per second, the velocity is getting changed in a negative way. Okay, it is negative acceleration. Okay, so if you will take some problem here, that is 20 meter per second is getting changed to 40 meter per second in 5 seconds. In 5 seconds, then what is the acceleration here? V minus u by t. That is v is 40 meter per second minus u 20 meter per second divided by 5 seconds. Yes or no? 40 minus 20, it is 20 meter per second by 5 seconds. That is 4 meter per second square. So the object is getting accelerated positively, that is 4 meter per second square. But in case of this is u, this is v, and let the time will be the same, 5 seconds. in 5 seconds. So A will be, acceleration will be v minus u by t. V is 50 meter per second minus 80 meter per second divided by 5 seconds. And here 50 minus 80, what is the answer? 30 or minus 30? Minus 30. Minus 30 meter per second. Yes or no? Divided by 5 seconds. 30 by 5, it is 6 minus 6 meter per second. So here you can see minus means it is negative acceleration or the speed is getting less when you are getting slower. And here you are getting faster. It's a simple definition, a simple idea. Okay. So it is minus 6 meter per second square. So negative acceleration is otherwise also known as deceleration. You can tell it as negative acceleration or deceleration. That means you are getting slower. Okay, according to time. So this is about positive and negative acceleration. Clear about it? Next, we will consider two examples here. Okay. So in this first example, you see an object is starting its motion from point A, then going to B, then going to C, and then going to D point. Here what is happening, when it is starting the motion, the time is 0 second and the velocity was also 0 meter per second. At 2 seconds, when we have observed the velocity of the object was 4 meter per second. At 4 seconds, again an observation, we found that it is 8 meter per second. At velocity 8 meter per second, it is moving. At 6 seconds, when we observe, the velocity is changed to 12 meter per second. Okay. So in this case, what is happening? The time interval you see 0 second to 2 second. Time interval is 2 second, 2 to 4 second. Time interval 2 second, 4 to 6 second. 2 second. So every 2 second time interval we have observed the speed. How that velocity is getting changed here? See, 0 to 4, that is 4 meter per second is change. 0 से 4 चेंज हुआ तो कितना चेंज हुआ? ना 4 मीटर पर सेकंड चेंज हुआ. 4 से 8 चेंज हुआ, कितना चेंज हुआ? अगेन 4 मीटर पर सेकंड चेंज हुआ. 8 से 12 चेंज हुआ, कितना चेंज हुआ? 4 meter per second चेंज हुआ. Yes or no? So here you can observe one thing. In each time equal time interval, the velocity is getting changed equal. First time interval में जितना हुआ, second में उतना, third में उतना change हुआ. Okay, so rate of change of velocity क्या है? Uniform way में हुआ है. Okay, that's why this type of acceleration is called as uniform acceleration. Getting? This is uniform acceleration. But in this case, see, the time interval again here 2 seconds, 2 to 4, 2 seconds, 4 to 6, 2 seconds. But observe this change in velocity. 0 to 3 हुआ, कितना हुआ ना? 3 मीटर पर सेकंड चेंज हुआ. 3 to 7 हुआ, कितना हुआ? 4 मीटर पर सेकंड हुआ. 7 to 13 कितना हुआ? 6 मीटर पर सेकंड हुआ. So in each 2 second, speed change or velocity change in a non-uniform way. Okay, that's why this type of case is called as non-uniform acceleration. Getting? Non-uniform acceleration. Getting my point? Uniform acceleration and non-uniform acceleration. In this case, velocity is getting changed uniformly, but here velocity is getting changed non-uniformly. Clear about this? Uniform acceleration, non-uniform acceleration. Then why this is happening? Uniform acceleration. Always remember, when constant force is applied to an object, constant force is applied to an object. Okay, uniform acceleration come into existence. For example, when one stone is falling from a height towards the ground, gravitation is pulling the stone continuously. Okay, that's why here constant force is applied on the stone, and this type of acceleration is uniform acceleration. But when you are traveling on a road, what is happening? It is a, let's say, a very good road is in good condition. You are traveling at a speed of 50 km per hour. 50 km per hour. After some time, you are getting on horns. So you have to apply brake. Yes or no? And your speed is getting decreased to 20 km per hour. Then again another good road is coming and your speed is changed to 80 km per hour. So here you can see the force is not applied on that vehicle constantly. That's why this type of acceleration is non-uniform. Getting my point? Clear about this? Okay? These are the examples of uniform and non-uniform acceleration. See this example. A bus decreases its speed from 80 km per hour to 60 km per hour in 5 seconds. Find the acceleration of the bus. Here you can see the initial velocity u equal to 80 km per hour. Final velocity v equal to 60 km per hour. And in how many seconds or how many time it is getting changed, that is t equal to 5 seconds. You can observe here, this is given, the time unit is second, here it is hours. Yes or no? So first what we have to make? We have to make this hour into second. Yes or no? Okay. So we will do this kilometer per hour to meter per second. Okay. So 80 km per hour to 60. If you will convert into meter per second, you can do kilometers 1000. 1 hour equal to 3600 seconds. So 80 into kilometer, 1000 meter divided by 3600 second. Getting? For meter per second we are getting here. To solve this, okay, 800 divided by 36 meter per second. Leave it here. Here you will see 60 km per hour. Same, 60 into 1000 meter by 3600 second. So it is 600 divided by 36 meter per second. Yes or no? Time here 5 seconds. So acceleration equal to v minus u divided by t. V is 600 divided by 36 minus u is 800 divided by 36, total divided by t by 5. So 600 minus 800, what is the answer? Minus 200 divided by 36. Okay, total divided by 5. If we can write like this, minus 200 by 36 into 1 by 5. If we will solve this, then it is 40. So it is minus 40 by 36 meter per second. You can convert into decimal or mixed number. Getting? So if you convert into mixed number, then it will be minus 1 whole 4 by 36 meter per second. Getting? And as you are getting minus sign or negative sign here, this is an example of negative acceleration, or that is otherwise called as deceleration. Clear? Okay.